For question 16.55, we have a few different things going on. We're adding solid silver nitrate to solution that contains 0.2 molar chloride and 0.15 molar bromide. Then we're asked, what is the concentration of bromide in solution when the silver chloride starts to precipitate? And you might be wondering, silver chloride, what's going on? I'm adding silver nitrate. Well, we're looking at the common ion effect. Yes, I'm adding silver nitrate, but silver nitrate is a strong electrolyte, meaning it's going to ionize completely to give me a silver cation and a nitrate anion. At the same time, I've got silver will react with both the bromide and the chloride to create a solid precipitate. So we've got silver chloride solid and silver bromide solid. Both of those are weak electrolytes, meaning I'll have an equilibrium between the silver in solution and chloride, as well as silver and the bromide in solution. And we're given the KSP values for both of those reactions. The KSP for silver chloride is 1.8 times 10 to the minus 10, and for silver bromide it's 5 times 10 to the minus 13. So we have the common ion effect taking place. I'm adding silver nitrate. I'm slowly increasing the concentration of silver nitrate until something precipitates, and then I'm asked how much bromide is left when the silver chloride starts to precipitate. Right, the silver bromide has the smallest KSP, which means it will precipitate first, followed by the silver chloride. So what we need to do is calculate the concentration of silver needed to precipitate silver chloride. Once we've found that concentration, then we can find when silver reaches that concentration, how much bromide do I have in solution. So the KSP expressions for both of these are pretty straightforward. The concentration of silver times the concentration of chloride, and the concentration of silver times the concentration of bromide. So step one, we want to find how much silver do I have to add to cause the precipitation of silver chloride. So I know the KSP for silver chloride is 1.8 times 10 to the minus 10. How much silver needs to be there when I have 0.2 molar chloride? I'm going to divide both sides by 0.2 to get a concentration of silver of 9 times 10 to the minus 10. So that's my concentration of silver when the silver chloride starts to precipitate. So now I want to go and calculate how much bromide would be in solution at that point. And right, remember the silver bromide would precipitate first. So silver bromide and the bromide has started to leave solution. How much is left when I reach this concentration? So again, I want to use the KSP for silver bromide, 5 times 10 to the minus 13. That equals my concentration of silver. Well, I know my concentration of silver at this point is 9 times 10 to the minus 10. How much bromide is left in solution? That's what I don't know. That's my unknown. Divide both sides by 9 times 10 to the minus 10. And my concentration of bromide at this point would be 5.6 times 10 to the minus 4 molar. So as you can see, quite a bit of that bromide, the majority of that bromide has already precipitated from solution. I started with 0.15 molar bromide, and I'm only left with 5.6 times 10 to the minus 4 molar bromide by the point that silver chloride starts to precipitate from solution. So this might have been a challenging calculation because you might have thought we had to do some calculation with the bromide first, but no, all they're basically asking is what concentration of silver do I need to have silver chloride precipitate from solution? At that point, when I reach that concentration, how much bromide is left in solution. So I want to do that calculation first to then use that concentration of silver to say, at this concentration of silver, what would be the concentration of bromide needed to reach that KSP value? And so we'd have approximately 5.6 times 10 to the minus 4 molar bromide left in solution.